Have you ever wondered what lurks in the deepest, darkest corners of our planet? Well, today we'll dive in nearly 5 kilometers below the surface of the Caribbean Sea, to a place where sunlight has never reached. This isn't just a journey into the abyss, it's a journey to meet one of the toughest creatures on Earth, a tiny shrimp that calls the 450 degrees Celsius volcanic vent its home. That's over 4 times the boiling point of water. Stick around, because the story of this immortal shrimp will completely change how you see life itself. Imagine a world of eternal darkness, where the pressure is so immense it could crush a submarine like a soda can. This is the deep sea, a place more alien than the surface of Mars. Down here, at depths of 5,000 meters, we find geological wonders known as hydrothermal vents. These are essentially underwater volcanoes, fissures in the Earth's crust that spew out a superheated, mineral-rich soup. They're often called black smokers because the water they release looks like thick, black smoke as it hits the near-freezing ocean water. The water erupting from these vents can reach a mind-boggling 450 degrees Celsius. To put that into perspective, your oven at home probably maxes out around 250 degrees. It's a toxic, scalding environment, filled with compounds like hydrogen sulfide, which is poisonous to most life forms. For centuries, scientists believed that no life could possibly exist in such extreme conditions. The deep sea was thought to be a barren, lifeless desert, but they were wrong. So wrong. In 2011, a British research team aboard a deep-sea vessel was exploring a vent field in the Cayman Trough, the deepest part of the Caribbean Sea. As their remotely operated vehicle, or ROV, approached one of these black smokers, its cameras revealed something astonishing. Swarming around the vent, in densities of up to 2,000 individuals per square meter, was a massive colony of shrimp. They were literally living on the edge of a volcano, in what could be described as the hottest place on Earth. This discovery was groundbreaking. Scientists had found life in deep-sea vents before, but never this deep, and never in such extreme temperatures. The team knew they had stumbled upon something special. They carefully collected samples of these mysterious creatures, and after analysis, confirmed it was a brand new species. They named it Rimicaris hybisae, a nod to the deep-sea vehicle that made the discovery possible. So, how on earth does this shrimp survive, let alone thrive, in a place that should instantly cook it? It's a question that has baffled scientists. The truth is, they don't live directly in the 450-degree jet stream. That would be impossible. Instead, they live in a temperature sweet spot. They crawl together in the turbulent zone where the scalding vent water mixes with the frigid deep-sea water. This creates a steep temperature gradient, where the water can go from 2 degrees to over 350 degrees in just a few inches. These shrimp are masters of finding the perfect thermal bath, but temperature is just one of the challenges. What about food? Down here, there's no sunlight, so photosynthesis, the foundation of most food chains on Earth, is impossible. The answer lies in a process called chemosynthesis. Instead of using sunlight for energy, the microorganisms in this environment use the chemical compounds spewing from the vents, like hydrogen sulfide. It's a completely different recipe for life, and this is where the shrimp's genius comes in. The Rimicaris hybisae shrimp have evolved a fascinating symbiotic relationship with these chemosynthetic bacteria. If you were to look closely at their gill chambers, you'd find they are packed with these bacteria. The shrimp essentially act as living forms, They provide the bacteria with a safe place to live and a constant supply of the chemicals they need from the wet water. In return, the bacteria produce organic matter, which becomes the shrimp's primary food source. They literally have a food factory built into their own bodies. They also graze on bacteria that grow on the vent chimneys, using specialized claws to scrape it off. But that's not their only superpower. Remember the eternal darkness. While they don't have eyes like we do, they've evolved something even cooler. On their backs, just beneath their transparent shells, they have a large, specialized organ. Scientists discovered that this organ is filled with photosensitive molecules, similar to the ones found in our retinas. It's not for seeing images, but is incredibly sensitive to thermal radiation, the faint glow emitted by the superheated vents. In a world without light, this shrimp can see heat. This allows them to navigate the dangerous temperature gradients, staying close enough to the vents for warmth and food, but not so close that they get boiled alive. It's like having a built-in thermal imaging camera. The life of the Rimicaris hybisae is a constant balancing act. They must navigate a world of extreme pressures, toxic chemicals, and radical temperature swings. They've adapted in ways that seem straight out of science fiction. Their existence proves that life is far more resilient and adaptable than we ever imagined. It can find a way to flourish in the most inhospitable places on our planet. Of course, life in the abyss isn't without its dangers. Even in this extreme ecosystem, the law of the jungle, or in this case, the law of the deep, still applies. The shrimp are not at the top of the food chain. Predators like deep-sea animals and fish lurk in the shadows, waiting for a shrimp to stray too far from the safety of the vent. It's a constant dance between life and death, played out in the crushing dark, 5 kilometers below our feet. The discovery of Rimicaris hybisae and other extremophile organisms that thrive in extreme environments has profound implications. It forces us to redefine the very limits of where life can exist. If life can survive in a full 5-degree volcanic vent at the bottom of the ocean, where else might it be hiding? Could there be similar ecosystems on other planets or moons in our solar system, like Jupiter's moon Europa, which is believed to have a subsurface ocean heated by tidal forces? These tiny shrimp are not just a biological curiosity. They are a beacon of hope in the search for extraterrestrial life. They show us that the ingredients for life might not require a gentle, sunlit world like ours. Life might be tough, tenacious, and hiding in places we've only just begun to explore. The next time you look out at the ocean, remember that beneath its calm surface lies a world of fire and darkness, a world ruled by pressure and extremes. And in that world lives a tiny, unassuming shrimp that has conquered conditions that would be fatal to almost every other living thing. It's a powerful reminder that our planet is still full of mysteries, and that the most incredible discoveries are often found where we least expect them. The story of Rimicaris hybisae is a testament to the sheer, stubborn, and beautiful force of life. Thanks so much for joining me on this deep dive into one of the ocean's greatest mysteries. What do you think is the most amazing adaptation of this shrimp? Let me know in the comments below. And if you enjoyed this journey to the abyss, make sure to hit that like button and subscribe for more adventures into the unknown. We'll see you in the next video.